Well, hi, good morning. It's August 30th here, and time to find out just what this unit can do now. So my objective initially is just to check it out, see if it does anything at all like what it's supposed to do. Does it work on its bands, all this kind of stuff. So this thing has some native functions, but it also has an added circuit to it. The added circuit is really kind of an after add, if you like. Has its own output terminal and that. So this is still connected in the way it was originally. This is the normal RF output here. So good chance that even if the extra circuit that's been added in doesn't function, this thing will still function in its native way or its original way. So I do have the scope connected here to the horizontal output here. I'll turn the marker amp off, set the sweep to minimum, the phase we'll put in the middle, this shouldn't matter. Find attenuator we'll leave at 10, which means there's no attenuation from this. This is a 100% attenuator. You put it to 0, there's no output left. You put it up to max, and then we'll leave this at ×1 for maximum output. We'll start on band D, and we'll just repeat what I did at the end of the last video. Let's make something happen on this little radio here, and then from there we'll start examining the output using my Sdr radio so we can kind of see what it's really doing. Okay, power on. I haven't put the light bulb back in, that's why the light hasn't come on. Put the radio on. You really can't tell if one of these things is working all on its own, can you? It doesn't do anything on its own. Okay, so we're going to swing this band D, swing this past the 100 here and see if we don't hear it on the radio. There it is. Okay, so that's exactly what I did at the end of the last video, and then I stopped. The sound is probably the sweep, because when I worked this, you can hear something happen. If I put this off, and then expand the sweep, interesting. If I put this way off, actually I'll put this way off, sweep up full, so that's about the bandwidth of the sweep. That would be from roughly 100, just using the numbers on the dial here. And this is 60 here. Probably a 40 megahertz sweep. Very good. Now we can't tell too much listening to that. Well, you know, we should check the marker amp too. Let's do that. Okay, so we'll put this one out of the way. And we'll adjust this and see if we can hear it. Marker amp, turn it on. Oh, it's right there. Silence. Oh, it's all over the place here. So this should be putting out a number. It should be putting out a main signal, I think. And then a bunch of side signals. Oh, there's all kinds of stuff coming out here. That's at 99 on this dial. Based on this crystal, I don't really know if the crystal's operating. A little loose here. Okay, so far so good. I'm going to just rearrange the video a little bit so we can look at the Sdr output while we fool around some more. Okay, I'm going to turn off the radio here. So what you see on the screen now is the output of my Sdr radio, output or a display based on the Sdr radio. And it is tuned to right around 100 megahertz. Huh, you see that go by? Now the Sdr is a tricky radio to use as an instrument. It's designed to be used as a radio receiver. So it has things like automatic level control and stuff like that, which when used as an instrument, like I'm trying to do it, is problematic. But if we just use our brains, we can accept what we see. Let's just move this right on to 100. Hang on a second, I'm going to put 100 right in the middle here. So this red line now is marking 100 megahertz. An odd looking display there. Let me turn off the marker amps. We only have one thing operating. The sweep is minimum. And we'll set it right on. A funny looking thing, isn't it? Yeah, the Sdr does stuff. So, but I think right there, whoop, right about there. That's about as good as I'm going to get it. So on there you can kind of see a square shape. There's something off to the right there a little bit, but just concentrating on the square shape. I believe that's the actual sweep. Now the sweep setting is 0. There's still a little bit of sweep going on, which is why we could hear a hum out of that radio. Let me expand the sweep here. Yeah, so there are some other things in the display. Like for instance, if you look on the right side at the waterfall, you can see it's kind of folded over there, or something's going on, something odd going on. Expand it a little more. Actually, the waterfall display gives you a nice idea of how broad the sweep is. I'll shrink it back down. Great, so that's happening right around 100, and the dial here, that's 100, that's 60. So the dial's about 85 or something like that. I'm sure there's some easy adjustments to bring this into alignment, but in the manual it points out that this isn't intended to be very precise. This is intended to be precise. Maybe not so much using the calibrated scale here, but because you've got a, yeah, I don't know about that. I'll take that back. I'll be going through the manual again now, looking at it from the point of view of an operator, not a repair guy, and probably pick up some more stuff about operating it. So let's get the scope going and see what's coming out of these terminals here. Should be able to see it. I'll just change some lighting. So the horizontal output here is just simply 60 cycles coming from the power line. Let's see if I can just get rid of some interference here. Okay, so that sweep is related to this, not to be confused with the sweeping of the RF output. This is just a sweep signal sent to the scope to make it sweep back and forth. And you know, we need an X input to do something with. What will we do with that? I don't, you know, unless we have actually a radio here to start working on. It's a little hard to imitate everything up there. Why don't we scope? Well, we can always change the sweep. Let's scope the output here and see what it looks like. This is the swept output. And, well, that's a really weird looking thing. Actually, if you could see it as clear as I can see it, it's really quite weird. It's really very artistic looking, sort of fancy thing here. What's that all about? I'm going to expand the sweep here. So not the sweep here, not this sweep, the RF sweep. Too many sweeps here. So why exactly it looks like that, you got me. Attenuator. Gets bigger again right at the small bottom. So 0 on the attenuator is like not quite 0, it's around 1. Okay, and the snap attenuator, well, this is going by a factor of 100. Okay, I'll change the frequency of the sweep generator. Where's that sound coming from? Now that sound is coming out of my computer speakers that are normally silent while I'm working in here. They're on, but there's no sound coming out of them. So that's not being... I don't know what's going on there. So that's around a frequency of 60. Interesting enough, 60 kilohertz. No idea why we would hear that, but we do. Okay, I'll put it back up around 100. There we are. Different bands. I didn't try the different bands on this yet. Let's go back and try that. Jeepers, I don't really have a radio receiver to receive them because a lot of them are odd frequencies here. So, well, I do. What am I saying? I've got the Sdr here, for crying out loud. Sure. Okay, so we'll switch to band C without moving the dial too much. It looks like 35 megahertz. So we'll jump down to 35 megahertz here. 35 would be... Oh, there's something there. There we are. That's at 32 and a half, but let me just move this. Oh yeah, that's it. And sweep width. Hot diggity dog. Hot diggity dog. Okay, next band. And the frequency is very close to the... This is actually coming out calibrated. I thought when I left the frame of the Increductor floating that we would have problems. So again, not moving this, we're around 13, 12, 13, right in the shortwave band. Oh, that's great. Shortwave band. What did I say, 13? I said 13, probably less than 13. Uh-oh. Oh, okay, so what has happened here is I've changed out of the high frequency band on my Sdr to the low frequency band, and we can't see things at this frequency unless I make a few changes. I actually have to change the Sdr antenna input on the radio itself. You may have the impression that I have a large shop here. I don't. It's tiny. It's tiny. You put two people in here and it's shoulder to shoulder. Okay, so we switch the antenna input. And we should be seeing something. No, I have to make another change now on the Sdr. Change the processing of the Sdrs. We just do that here. From quadrature sampling to Q branch. Play this baby. Now, so we think we're around 13 or less according to the dial. I didn't see anything in there. Okay, so we'll put this around 13. We'll just swing this. It's actually easier to move this. Oh, there it is. You know what? We're right on 13 here. Dead on it. Hey, thumbs up on this guy. Let's try the sweep. Well, kind of moved it right off. Not sure what happened there with the sweep. But something's happening. Anyway, let's go right down to the low frequency. I dialed in 6 megahertz. Will you produce a 6 megahertz signal? It's all through the shortwave band. This could be really handy. That's fun, and it'll sweep down here too. Okay, so we're on 6 megahertz now. I don't see anything there. Let's go looking. Maybe nothing on this band. carefully. Oh, there it is. Just below the red line there. Well, there's something there. Sweep width just wiped it right out. It came back somewhere else. It's small and weak, but it's there. Okay. Oh, and we're dialed in. We think we're around, like this is around 8 megahertz, and this is showing up around 5. Well, what's up around 8? Just in case. Nothing moving. Just go above 8 a little bit here. Nothing moving. Very good. Now the marker frequency goes down to 19, all the way up to 180. There's no band selection here, but there are 2 scales. So I think it's producing a harmonic or something of that sort. So if you dial it here, where one scale says 72, the other one says 24. 24 times 3, 72. That's exactly what's going on here. So you just multiply by 3 to come across. So right now, this guy should be putting out a signal at 72 and 2.5. Okay, so let's go looking for it. Turn it on. Turn it up. 72 and 2.5. No, not 2.5, 25. And where are we? Okay, let's go up around 25 and see what we can find here. Okay, so that's 25 in the middle. There it is. There it is. Oop. There it is. That's 25.5 on the Sdr. 24.5 on here. Very, very close. And now there should be another signal at 70. Well, it'd be double this, wouldn't it? So it would be double 25. It would be a 50. No, triple it. 75. Okay, let's go up to 75 and see if there's something there. 75. Anything move? Anybody moving? This is up full. Full. Everything's full. Well, I don't see anything. Did I do this right? We're 75. We're right around 75 now. Oh, there it is. Okay, it's there. And it's actually set to about 68 or something like that. Well, excellent. Output on all bands, except maybe the A band's very, very weak. But the band I'd be most interested in seems to be working. Now, what about this crystal here? The crystal is supposed to create, this is a 4.5 megahertz crystal in here, and it should create a pip every 4.5 megahertz. My Sdr screen is only about a megahertz wide. It's not really great for this kind of thing. The pip. So I'm going to stop. I'm going to read a little more about operating this unit, because that's what I'm doing, and I just realized I've been doing all this with only 92 volts on it. Oh my gosh, that's incredible. That's great. Goodness knows if I put the full voltage on it, it's only going to be better. Better and better and better. So we go back to the 20 something. Let's just see what happens here. 25. Okay, where is it on there? Where is it? Where'd it go? in here. I seem to have lost it. Okay, let's do this. We'll give it full power. No, I want to do this more. I want to find this on the SDR and then throw the switch and see what the variation in the B plus does to the oscillators on this. Why can you not be seen now? One thing, I don't have this closely coupled. I can make this closer. Let's try that. I'm not sure that's really much better. Oh, there it is. There he is. Okay, good. Very stable oscillators in here. When I let go of the control, it freezes, frequency-wise. Okay, so now I'm going to up the voltage to the proper voltage, and we'll see if that frequency moves. I'll put the red line on it because I think it's easier to see than where it was anyway. Okay, red line. Red line's right on it. Okay, full power, please. It seemed to move ever so slightly initially, but right back. Wow, okay, totally insensitive to B plus changes. Fantastic. Yeah, so I'm going to stop now, go away, and read up on how to use this properly. And there's probably some instructions in the manual on the initial tests, and then there's got to be some frequency calibration steps that can be taken too. Excellent. Okay, so I've read through the manual very thoroughly, and something we need to do right away, I think, is find out if the marker crystal is actually generating a signal or not. But I think the first thing, this has been on for quite a while, and I can feel the power transformer back here is pretty hot, so let's just see how hot it is. 48 degrees, above 50 degrees. So that's, now this has been on for a couple hours here, I think. So that's probably its top temperature. That's quite warm though. A little warmer than what I would want to see. Okay, now how do we figure out if there is a marker frequency coming out of this? So the crystal that's in here right now, it says in the instructions you can pull these out anytime you like to actually shut them right off if you want. Snellgrove Company Limited, Toronto. Oh, this is a 3. Oh, no wonder I can't find it at 4.5. This is a 3.037 megahertz crystal. What an odd number. Let's put it in there. And what we'll do is we'll just look on the SDR right around, what did I say it was? Right around 3 megahertz. We'll see what we can find here. Around 3. Oh, there's something right here. Well, that's 3.2. What was this crystal again? So that frequency didn't disappear. It can't be from this crystal. Just over 3 megahertz. 3037. And we need to have this turned on. That's probably, oh, it is on. It is on. Okay, and we're trying to pick up the marker signal at the output, which is fine. Should be there. What happened there? What happened there? What's going on here? I think I'm swinging it like a long distance without realizing it. Okay, so that's the variable oscillator. What frequency are we looking at on the SDR? 2.6? How do you get 2.6 out of this? Well, I'm not to complain. So there's lots of harmonics in this thing. It's depending on harmonics to do a lot of stuff. It's mixing signals together to generate products. It's depending on those in its operation too. So it's actually quite a complex little instrument to get a complete grip on it. Let's get back to this guy. It doesn't seem to be. Well, we can take an output from the marker generator right here, and we can take a look at it. And by the way, the signals coming out of this are quite low. Less than a volt on the FM here, quite a bit less. So what we'll do is take this off. This is connected right to the scope. Go on here. Okay, so I see there's a big signal. You can see it on the scope here. Big RF signal. So we're using the sweep coming out of here to cause the sweep on the scope. So something's there. What's on the SDR? Whoa, there's a great big thing at 2.6. Okay, let me turn this. And so this is the variable oscillator. You can see now, this looks very, very much like what I see in radios all the time, with multiple signals traveling in different directions, all bunching up in one spot right there. So these effects I've been looking at for years now as I work on radios and use the SDR to do things like I'm doing right now. And I appreciate the idea that they're probably mixed signal products and things like that, but to have an absolutely firm grip on it, I've never done it. But I'll bet you this machine will help me figure out what is going on. So where are we at? So I've collapsed those things down by moving this, I think, right on top of the crystal frequency. I think is what I'm doing, because the frequency we're at here is 3.035. And the SDR has some accuracy problems. The reading, the numbers here on the SDR can be out quite a bit. It has an adjustment over here to compensate for it. Somewhere here. Shift. This one, shift. There's 0 right now. Because the radios are not perfect. The receivers, nothing's perfect. That seems perfect. 3035. Isn't that what was written right on that crystal? It's a 3037. Pull this out. It didn't go away. Well, that's because I'm beating this signal on top of it. So let me move this one off to the side. I plug this back in. I think another signal will end up at 3037. So did something show up there? Something did show up. We got something here. The distance from here to here is repeated, and is repeated this way. And I'll bet you if I move this frequency, this is the variable one, towards this one, these distances here will also decrease, and the whole thing will collapse in on itself right here. Are you telling the truth? Let's see. Oh, I am getting a grip on things. I am getting to understand what goes on here. I'm right past. So there we are. So I think it's possible that I should calibrate the SDR against the crystal here. The crystal can be that reliable. I have another one. I have another crystal here. It's a little bit of a different. Both are different. This one is more interesting. This is 5000.000. I watched a video on how these things were made. Can you believe it? That there comes a point where they have the crystal now pretty much exactly the right size. They put it into a test jig to see what frequency it's at. And they got out a file. And they're manually filing them a bit and seeing what frequency they're at. And then filing, women were doing this, where they were making these for radios. I couldn't believe it. And they also showed the source of the quartz for something like this. It's from a quartz rock. I think it was somewhere in South America. This super duper pure quartz that they were chopping out of a mountain in big chunks like this, beautiful clear chunks, sending it up to this factory, which was chopping it down into little pieces and then filing it to achieve the exact frequency. Is that what they're doing today? I don't know. I don't think so. Let's pull this out. Put this in. I don't think it's going to go in. Not going to go because the posts, they're the right spacing, but just way too small. Okay, so we're stuck with this one. Point is, we know it's working. Let me make sure this frequency, yeah, there's nothing there at 3.037 right now. I put this in, and there it is, 3.037. And then all the other signals showed up too. Thank you, SDR. If I didn't have an SDR with this sweep or spectrum display, I don't know how the heck I would ever come to grips with this stuff. So once again, SDR to the rescue. Okay, so oscillator working, crystal oscillator working, marker working, sweep working. I read the alignment instructions. They're pretty simple. This one, you don't do too much. You just make sure when you go all the way this way that the knob reaches a certain spot, which I don't think it is. I think it should be down here somewhere or something like that. The accuracy of this oscillator is not important. According to them, during the operation of the machine, it's sweeping anyway. The way you use it, you don't need this to be accurate, so the dial is just giving you an idea where you are. You should be looking at your scope while you're doing the test to get this where you want it. This is intended to be very accurate. Accuracy primarily coming from the crystal and the observance of the crystal effects, mixed signals and markers along there and all that. And you can even use this in calibrating this guy during the setup, which is possibly what we're going to do here. Although this is not the crystal that was supplied with it. And I have this terrible feeling I've got a little box with 3 or more of these crystals in it somewhere in my house, which I wish I could make come true right now, but I haven't been able to. Okay, so what more can we do with this? A little calibration stuff. Without actually putting it to work on a circuit to ensure that it's operating. Well, I think I'm pretty much there at this point. I think I need an actual circuit now to hook this into and to further experiment with this. Now what I've got an FM receiver I'm part way through calibrating. In fact, I'm working on it. I stopped in order to fix this guy up, thinking that maybe this would be useful. Wow, that was so long ago I can hardly remember anything about this receiver I was working on. So an option here for me is to bring the receiver in. Hold on, we have another whole circuit in this thing to investigate. And that is the added tube that's sitting right here. These white clip leads, by the way, are grounds that I had to put on because of the native ground I removed. So that's what those clip leads are. I can make that stuff permanent, of course. Yeah, so what about this other circuit? It's supposed to produce something down here. Why don't we look at this, see what we got coming out of it. So what I can do is put this connector on here. These are not my favorite kind of connector. Okay, we'll put the scope on here. So the idea of this is there should be audio frequency sounds here, like pips that are occurring with the sweep. The idea is the audio bandwidth is tiny, right? It's just, I don't know, 50 cycles, 100, whatever it is. It's in hundreds of cycles, whereas the bandwidth of the circuits that are being aligned are in thousands of cycles. So you can make the pip very, very small relative to the RF signal. That's the idea. So apparently other sweep generators do this. They tend to do it internally. This one, because it's an added feature, has an added connector and an added signal. This is supposed to go right to the scope along with this. Just mixed together at the scope terminal. Something like that is supposed to be done. Plus, this is supposed to have a properly terminated output if you want to get serious about things, and I don't have such a thing right now. I would have to make it. So this is 50 ohms here, I have a cable come out to more terminals, and a 50 ohm resistor in there just to terminate it properly. I don't have that cable. Didn't make it. So I'd have to build one of those if I want the calibrated type effect. I may have some other opportunities here. So what's coming out of here? How can we look at it? Well, we'll just look at it with a scope to start with. We'll see what we can see with it. This is a ground terminal. It's handy. Think this is going to grip it? No, it's not going to grip it. Since it's audio stuff, I don't have to worry about the long clip leads and stuff. Nothing on there now. To engage this extra circuit, probably need to generate the audio tones by using it in a way it was intended, or mimicking the way it was intended. So that means a sweep signal crossing a marker signal and producing an audio signal. Boop, 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 boop. And then putting a pip on my scope, which you can't see, but nothing to see yet. Anyway. Okay. Well, we know this is at 3 megahertz, and we know if we set this at 3 megahertz, we start getting lots of stuff, maybe some audio stuff. Audio level stuff will come out of here if I do that. So, and we got it up on the scope, don't we? No, we don't. What are we doing with it? No, we're scoping it here. Yeah, that's good. That's good. Okay, here we go. Did anything show up on the scope? I may not have thought this through quite properly. There's nothing happening whatsoever on the scope. Nothing at all. Lots of funny stuff on the Sdr. I'm sweeping this back and forth. So, 3 megahertz. Okay, so the red line at the center of the Sdr is the frequency of this guy here. Going up and down a bit. If I touch it, everything's going up and down. A little bit of sensitivity there. Okay, move this right on top. See all those side frequencies? Eventually they get down to audio level. But that's not coming out of this machine. So we look over at the scope now. There's just nothing showing up at all. So under this test, the impression I have is the added circuit isn't doing anything. Doesn't do anything. Scope, sensitive, DC here. Well, that's okay. Beyond DC is better. Oh, times 1. Well, let me change my probe setting here to times 1. Okay. Just fooling around here. Okay, let's try this again. Looking at the scope, it's just nothing happening. A little tiny action here, but it doesn't move or change. Marker amp. What if we turn it way up? Some dirt and noise showed up there. No, I'm just shooting in the dark here to see what would happen. Nothing. Certainly the impression is nothing out of this additional circuit. The idea of the additional circuit is to give you the tighter, sharper pips. But in my application, and having seen what's already up on my scope in terms of the size of the pip coming out of this, I don't know how necessary that is. Secondly, the calibration issues melt down if I plug a frequency counter into this guy, and then we know exactly what frequency it's producing, which I think is a good idea too. You put the signal generator on here, and we know the precise frequency of this. The device is built around the idea that this is a a precisely known frequency. Just my technique using the counters a little bit better, a lot better. Then this thing's pretty well ready to be put to work. Yeah, I think so. So what did I say I was going to do? I was going to do something, and then I just totally forgot. I'm going to go look more for these. I can find more of these guys again. And I've put them in a special spot. That's what I've done. Yeah. And then I don't know. I don't know. We'll see what I do next. So I think the best way forward for me with this, and bearing in mind I have a receiver, that's really is what I'm trying to work on, is to bring that receiver in here and then mess around with this guy with the receiver. You know, it's a good idea to do something like this with a, let's say, a device like a receiver that's in perfect working order. Then any weirdness you can attribute to something like this while you sort stuff out. But if you have one guy that's got question marks and you're hooking up to a receiver with a bunch of question marks, then it's really question marks of the question marks, or what is happening. So it might be a little screwball to try that. But I think at this point it will help me understand this a little better too, and get a little closer to the idea of can this really helpful? Can this really be helpful? How do you really use it? All that stuff. And as for the adder circuit, the additional circuit which appears to not be working, I'm not going to worry about that right now. I'm going to concentrate on the inherent functions of this machine. Great. Hey, thanks a lot for watching all these videos on this. Hopefully the next thing will be real interesting. Hopefully.